And then it's recording, so now we can pause.
Okay.
And for everybody else on the phone, so please put yourself on mute so we can hear Jonathan much better. All right, go ahead, Jonathan.
Okay, thanks very much, Shirley. And good morning, everybody. Thanks so much for joining. It's a real pleasure to have an opportunity to be a part of the speaker series. It sounds like a really great program that you folks have on a regular basis. So, as Shirley mentioned, my name is Jonathan, and while I make no claims to have any secrets to share with you today regarding software quality, I do have a fair bit of experience in shipping software and working with companies to improve the software life cycle. So over the past 18 years of my career as an engineer and a team leader, I've experienced on many occasions firsthand the challenges and pains around delivering high-quality applications on time. And what that did is it led me to join a good friend of mine in 2004 and start a company called Replay Solutions. And what Replay Solutions is all about is helping teams accelerate their development and test cycles with some very unique technology. And I'll touch on that a little bit later. But in 1999, some of you may recall a technology that started to become popular called TiVo. And this is a technology that really inspired us. And it caused us to ask ourselves, why can't we do the same thing for software that TiVo does for television content? And why can't we automate the capture and record and replay of problems to really help some of the challenges that we were feeling and facing firsthand? And so in 2004, we founded Replay Solutions. And as the founder of a company in the software quality space, I get a chance to spend a lot of time working with companies that are struggling with some of the same challenges that we all face as we're trying to deliver modern applications. And so we'll talk more about those challenges later, but one of the nice things about working with so many teams, both large and small, is that I've had the benefit of being exposed to many different workflows and approaches to software quality. And, we specifically work with a number of large financial services companies like yourselves, and I've had a chance to see, what works and where teams seem to struggle. And so as a result of that exposure, I've been fortunate enough to have the opportunity to share some of those ideas at conferences and through articles and talks like this one. So for today's talk, what I'd like to focus on are two trends emerging in the software quality and the software lifecycle space. So we're going to discuss those trends and then have a look at some of the workflows and the tools that are currently in use at companies of a similar scale to Morgan Stanley and see how, really have a discussion around that. So I can't promise you that I'm going to impart any radical new concepts or knowledge that you don't already have, because I've worked with teams at Morgan Stanley in the past, and I do know that you folks do have some great best practices. But I do hope that we'll be able to give you some good nuggets to take away. So this is an open mic discussion. We will have time at the end of the latter part of the hour for Q&A and some discussion, so I'll look forward to that. So let's jump in here and just sort of cover why we're all here. And again, this is something that I think everybody will identify with. Our software in 2011 has really become much more complex than it ever has been before. And why is that? Well, our applications are composite. We have heterogeneous technologies and different types of systems and different locations where we're deploying applications in the cloud, in private clouds, and public clouds, in data centers. And our teams are distributed more than ever, as evidenced by this call. And all at the same time, we have this high demand for a much faster velocity, and that's where Agile comes in. But we really need to deliver software faster and at the same level of quality. And so all of this is compounded by the fact that our code bases are growing. We have millions of lines of code to deal with, and the complexity in general is rising with all these new technologies such as Web 2.0, AJAX type applications. So what are the drivers that are really causing us to look at automation and other types of tools and workflows? Well, number one, as I said, we really need to keep achieving velocity. And that's where Agile comes in. And I'd love to hear maybe when we get to the discussion a little more about how Morgan Stanley is employing Agile methodologies or how you plan to. We're using test automation more and more. I think most teams are trying to employ automation as much as possible. And they're also putting in place continuous integration and expanding and enhancing their continuous integration. One of the things I'll talk about is some specific examples around continuous integration, which I've seen at some large companies, which I would recommend as best practices. I've seen them be very effective. So it really all comes down to managing software complexity. And software complexity is really all about change. It's understanding when change is going to impact our software as early as possible, as far upstream the process as possible, and making sure that we have the processes and the intelligence in place to deal with that change effectively. And so if we go through here, change is really our enemy. If we didn't have change in our software, we wouldn't have any problems. It probably wouldn't be employed either. But so here we're going to talk about some new methods for really attacking and defending against that change, which is really the cause for a lot of the defects and quality issues that we all seem to experience. Okay, so having said all that, let's get into one of the first trends that I want to talk about, and this is something called application lifecycle intelligence. And I've got the TM up there because this is a moniker that was borrowed from the brilliant minds, marketing minds at HP, and it's a label that they put on this concept, which I'll discuss. And I think it fits really well, and I think you'll agree as we dive into it. You may have already heard about ALI from some of the conferences or events you might have attended. But when we get to the Q&A session, I'd be really curious to hear if any of the folks on the call here have any experience with some of HP's ALI modules. But I'm going to talk about application lifecycle intelligence in kind of a broader sense, because there's a lot of vendors and initiatives to sort of subscribe to this concept of ALI that are trying to really enable collaboration and correlation across your life cycle. So ALI is really about understanding change in your software, identifying the hot spots where those changes can affect quality, measuring that, quantifying that with some metrics, and then focusing your quality efforts around those risk areas that are essentially those hot spots. And if we can correlate those risk areas with the requirements, the tests, and ultimately the code changes, we're in a much better position to rapidly respond to any defects or test failures that come up during our process, especially if we're employing Agile methodologies. And so this is really the goals of ALI, and let's go ahead and talk about some of the actual implementation details behind that, or some of the concepts. So here's kind of a common workflow chart, if you will, and you probably see this from a number of different places, whether it's vendors or talks. We start over here. With our requirements. Our business analysts get together and define these requirements, which are then broken down into tasks by our teams, and those tasks will translate into code changes to fulfill those tasks, as well as tests, which will map back those tasks and requirements. And then as we go through that cycle, we often encounter defects, unavoidably. And those defects will lead into risk management planning that our project managers will take in through the dashboard data and through the defect tracking systems to help mitigate risk in the project. So application lifecycle intelligence is really about correlating when things go wrong between these different phases in the life cycle. So, for example, if I have a defect reported because of a test failure, well, that test failure is going to be related to that test case is going to be related to some requirement. And that requirement is going to be related to some tasks, which will in turn be related to some code changes. So if I have that interconnectedness, that knowledge transfer happening, and that correlation of data, when I have a defect corresponding to a test-based failure, I can take that information and I can actually run it back and understand, well, which code changes were responsible for this defect. And it's possible to make that a fairly quick correlation if you've implemented or if you're using some of the application lifecycle intelligence principles, which are make sure that when code changes come into your code base, they reference the requirement that they're relating to, or at least the task, which obviously would then cross-reference to the requirement. And with that in place, you'll have that correlation. So this is something that really helps you understand change better, understand where the hot spots are, and measure risk much more effectively, because you'll know if I have a requirement, for example, that required 50 code changes and several thousand lines of code, well, that's an area where I really know there's likely to be a higher degree of risk, and I can focus my testing around those areas of the requirements. So let's look at sort of how that manifests itself in terms of an actual workflow. So as I said, now if you make sure in your workflow that any code changes that come into the code base reference the requirements, when your test case fails, the defect that is created as a result of that test case failure can actually reference the requirement. And it's a very quick process to do that. And as I said, there are a couple of vendors that are now providing solutions which allow you to make that correlation. HP is one with their ALM solution, and they have something called ALI, which fits into that. IBM is another one, and Microsoft is also charging ahead and filling in the gaps to provide this kind of intelligence and correlation across your whole life cycle. So the whole point here is that when something does go wrong, you can very quickly identify the code changes that resulted in those defects and keep your team agile. And when something does go wrong, your project managers have the ability to understand better what the likely risk is of a particular code failure or test case failure. So that's an overview of the correlation. I'm going to move on now and talk about code coverage, but I'm going to, most people are familiar with code coverage. I want to talk more about, some of the advanced uses of code coverage in the context of lifecycle intelligence. So this is more than just the traditional approach of getting a percentage of coverage that your test cases are, looking for the biggest holes to fill. And by the way, the screenshot showing here is from a Java code coverage tool called Clover from Atlassian, and this is a great product that will help you really understand. This is a heat map that you're looking at, which shows you graphically the different areas of your code where there is or is not code coverage. And the idea is that you would actually have the code coverage running during your test automation suites or your manual testing to see, well, how much are we actually covering. But so that's kind of the basic code coverage. Most people are probably familiar with that. But if you couple the code coverage change reports with understanding where change came into your software. So if I know that I have a hotspot or an uncovered piece of code where my automation and my regression tests and my unit tests are not touching that code, I can make an intelligent decision to say, well, if I have a choice between two hotspots where I don't have good code coverage, I'll focus on the one where I've actually had change in the past, several weeks, for example. If I know that certain code changes came into the code base specifically to address a requirement and they affected said area, well, I'll focus on that as opposed to focusing on the area that lacks code coverage that maybe has been stable for a number of releases. So obviously our goal is to get as close to 100% code coverage as possible, but when you have the ability to correlate where code changes are coming in, you can be more intelligent about responding to your code coverage reports. And so this all comes back to risk-based testing, looking at where is the most dynamism or where is the most change in my software, and how can I effectively respond to that. Okay, so the next thing I want to talk about, which is also part of this lifecycle intelligence, is also understanding the effect of change on your software as well. So understanding how change affects your software through continuous integration is very key. And the sooner you can get that information, the further upstream you can understand the impact of a code change, the much better it's going to be for your whole team. So with the ability of some of these tools, and what I'm showing you here is actually a screenshot from a tool called AppDynamics, which is a very good product from a fairly young company. And what they're able to do is tell you, here are the differences between the previous build and the current build. And by quickly having access to that information, either in tests or in production, you have the ability to respond very quickly to any changes that might come in. And these might not be test failures. You might have changes come into your system that, for example, change the application behavior somehow, increase the error rate, but maybe not trigger a test failure. Maybe the number of exceptions will rise. Maybe your memory usage will be inconsistent from the previous build. If you have that baseline set of automated tests running, you can actually detect even minute changes in the behavior of your application as a result of code changes coming into the software. And looking at, are these numbers going up, are these numbers going down? Because not all defects are fatal or are going to result in a visible error. So having a tool like this has been really effective, and specifically talking about one of our large ISV customers has used this very effectively to early and effectively track where code changes are impacting, for example, their performance or their memory usage. When you're trying to track down minute changes in memory usage, it's often difficult to do that with traditional test cases. You really need tools that are going to tell you, oh, that last code change resulted in a 2% increase in memory. And when you get 5 or 10 2% increases in memory, that's obviously going to create a problem very quickly. So being able to respond to that at the time the actual code change goes in is really important. And that's been really effective for this team. And I'll talk more about that specific example a little bit later when we get into the continuous integration discussion as well. All right, so go ahead to the next slide. And this is one of the ones that's kind of one of my favorites. So, and this comes back to more of a cultural impact of the application lifecycle intelligence. And it revolves around communicating quality metrics clearly to the entire team. And, a quick story, I've seen this be very effective in terms of, you can see I've got a photograph up here of a team that has some large monitors posted up right in front of their application team. And those monitors are showing a large number of metrics. And I'll get into that. But I recently walked into the office of a large online retail company, and I was just struck by the way their application teams were communicating quality. What they were doing was treating their build quality much like a NOC, or a network operations center. It was Houston in there. They basically had a series of large flat panel screens up on the walls, actually quite a bit more impressive than the screenshot I'm showing you here, but those LCD displays were showing multiple sets of live metrics. They were showing metrics around latest code changes and check-ins. regression and unit test percentage pass and fail, their test automation reports, performance metrics, code coverage reports. They were reporting on code complexity. Their static code analysis results were being shown in there. And all of that information was being updated in real time as changes were coming in. And the interesting effect of this was it really established a mantra of quality and a sense of ownership with the team. When those dashboards lit up red, there was an overwhelming desire from the application team to get together, collaborate, and fix it. And there was also a sense of responsibility that gets fostered in each team member to make sure they're not the ones who end up setting off that alarm. So, this is something that really kind of generated a real sense of, team spirit, team ownership, and it really put quality front and center. Oftentimes for developers, they don't think so much about quality. You start posting those metrics, and when a code change that they made results in an alarm going off on one of those dashboards, believe me, they think twice about being sloppy with another check-in in the future. And so these are really effective about getting everybody on the same page, making sure everybody is thinking about quality. Now, the one thing I will mention is it's also very important that for this to be effective, the occurrence of false alarms must be very rare. If you have these dashboards throwing red alarms, red alerts, too often when they're not truly issues, and that's not that hard. It's easy for that to happen. The system starts to be thought of as Aesop's little boy who cried wolf, and it's going to lose its effectiveness pretty quickly and become more of a pain to people. And then people start to assume that it's the system that's wrong, not an actual problem in the code. So, but these dashboards have been extraordinarily effective. It's one of the best things I've seen teams adopt in terms of really creating an environment and a mantra, if you will, of quality with the teams. So having dashboards like this is not hard to do. These flat panels, as you probably know, are about $500 now at Costco. You can pick them up, throw them up on the wall, and get started pretty easily. For myself, the actual end goal would be something like this, of course, which will be the ultimate in software quality dashboarding. Little tongue-in-cheek, this is actually a shot of the AT&T Global Network Operations Center. It's one of the most impressive rooms I think I've seen. You should Google that one. But they're very serious about their dashboarding. All right. So let's keep going and get on to the next topic. And I think we're doing pretty well on time. So the next trend I want to talk about is more specifically around software automation. We've talked about application lifecycle intelligence. We talked about some of the concepts around that. Now let's talk about some of the automation principles. So just start off, why do we need automation? Well, clearly we cannot test everything. It's simply not possible. The velocity that is demanded of us requires us to employ automation. And furthermore, as we get more agile, we need to push quality upstream. We need to start that process earlier. It needs to be done during development. As soon as those requirements are defined, we need to start the quality process. So how do we do that effectively? Well, there's a couple of important techniques that I'm going to talk about, and just referencing the million monkey and a million keyboards idiom. If you're not familiar with that one, just Google it. Basically, we're saying there's no way that we could do this testing manually. So, all right. So let's talk about some specific things around test automation. So I'm not going to talk about some of the basic things in terms of automated testing tools. There's a lot of great tools out there, open source and commercial. Here's a few that we come across very regularly. They're all great tools. There's others out there as well. I don't mean to leave any tool out of the picture here, but the point is, this is something that is a fairly mature market in terms of test automation. So most application teams will have implemented some level of test automation, and that's great. It's very important to do that. So what I'd like to talk about specifically is continuous integration, and how does our automation work into a continuous integration environment. So hopefully everybody's familiar with the concept of continuous integration. I'm going to assume that we are. One of the best tools out there today is Hudson. There are others. There's some other great commercial tools as well. Our team uses Hudson. It's worked extremely well. It's very versatile, and it's a great community behind it. So what Hudson allows us to do, obviously, is really schedule certain things, certain tasks, certain tests to be run every time there's a code change. So continuous integration is truly critical. Our mantra is always be testing. You've always got to be testing. In some capacity, every code change that comes in has got to be tested. And so both ourselves internally, and I'll talk about one of our customers, which is a very large ISV, a multi-billion-dollar company, what they've done extremely effectively is implement a system through continuous integration using Hudson that every time there's a code change, that will trigger a whole suite of tasks to be run. Again, probably nothing terribly new for you folks, but I'm going to talk about what happens through the system. I think it's quite interesting. I thought it was just a great best practice. So as we're going through these code changes, what happens on every check-in is there's a whole suite of unit tests and regression tests that are run. There are automated performance metrics that are collected to give us those change reports that we talked about earlier. It's also running code coverage during these unit tests and regression tests and performance metrics so that they know have the code changes decreased my code coverage. Are unit tests being written simultaneously with the new functionality to cover the testing of that area? And are those unit tests actually doing their job? And that's also a very important question. So the code coverage reports that they get are key, but they're also doing a high amount of static code analysis. And what they're doing with that is checking not only for bugs or potential defects in new code, they're looking for other things, which I'll talk about later in terms of duplicate code and security issues. And as a result of every single check-in, what's happening is that a complete packaged build with an installer is being created for every single build. So they know that if that fails, something along the chain has failed in terms of that code change. And what happens is they actually reject that change and kick it out of the build system. Now, they have some different rules depending on which branch of code, whether it's the production branch or a development branch, or a patch branch. But generally, they're going to kick out any failure, any check-in, or any code change that results in some failure in that continuous integration process is going to result in that change being kicked out of the system and rejected and reverted back. So this is one of the best practices I've seen implemented. And the reason for that is it really helps to avoid the compound issue when you have change upon change and then find yourself having to go back, spend 2 days understanding which of the 15 or 20 check-ins that just occurred was responsible for a specific failure that was buried deep inside of the application functionality. So, the old adage about the cost of a software defect rising logarithmically or by orders of magnitude as you progress through the software life cycle really holds true here. The further upstream you can identify and resolve these issues, the faster you're going to be, the higher quality and the better velocity you'll achieve. So this is something that I really would recommend. I've seen it be extremely effective. We practice it ourselves, and I've seen that some of the most effective customers that we have at large companies put this in place and employ it rather ruthlessly. So here's just to drive the point home. If you've got something that isn't passing those tests, some of the best practices would recommend just kick that change out, make sure that it doesn't get into the code base. And it's quality's job to enforce this. This is something that is really or should be in the domain of the quality team, the QA team, and not the developers, frankly. There is that kind of balance in the universe that must be maintained. So that's the piece on continuous integration. I want to drill down a little bit deeper and talk about some of the static code analysis pieces that I mentioned. So static code analysis is very effective, and there are static code analysis tools out there today, such as Sonar, which is more of a framework, Find Bugs, Fortify, that are providing different functionality, which is extremely important. And that technology, Coverity is another great vendor of static analysis tools. But this technology has come a long way in really helping to, again, identify issues as far upstream as possible. And it's not just something that the developers should be running on their own. It's something that can be part of your continuous integration system, and it's something that will help you in terms of not only identifying code defects, but things like duplicate code. Duplicate code is extraordinarily dangerous. If you have code which is duplicated in multiple locations and there's an issue with that code, it's very often difficult to track down every instance of that duplicated code to make sure that the fixes get into all the right places. So having a tool which goes through and applies some fuzzy logic to identify duplicate code, because they're often not byte for byte identical. Having the ability to go and identify that duplicate code is really key. And specifically talking about one of our large financial services customers that I work with closely, that's a key feature. And another feature which they've implemented themselves as a homegrown static analysis tool is something they use to capture complexity. So they're looking for complexity in the code, and they measure that complexity with something called the Developer Efficiency Index. And the idea is the less complexity you have, obviously the better. So by assigning a metric, teams are actually even rated based on the complexity that they add to the product. And believe me, in this case, less is better. You don't want that number to be high. So having the ability to, once again, identify changes in the complexity of your code early on gives you a much better chance to avoid having to deal with downstream issues that result from that complex code, perhaps when that person is no longer around or available to look at the code in a few months' time when something actually goes wrong with it. Keeping that complexity down, whether it's a developer efficiency index or some other metric, is something that's been very effective for this team, something I would certainly recommend as a best practice. Using some of these analysis too, for example, the code coverage analysis, is also a great tool for helping us understand how effective our automated testing is. So obviously, if we're adding change to the code base and it's increasing or decreasing the code coverage, that's going to be a great indicator for us that we need to focus on certain areas. So this all comes down to developing risk metrics and helping project managers and QA managers and development managers understand those risk metrics. Where is risk creeping into the product or the project? How do I mitigate that risk? How do I effectively tackle that risk early? And these are tools which really help you to do that. Okay, I want to move on and talk about another new technology that's fairly recent, and it's something called service virtualization. So I'd certainly be curious to hear if any folks on the line are familiar with service virtualization. And this is designed to, once again, help teams implement the quality aspect of their project earlier on. You know, a lot of times the challenges around starting the quality and the QA and the testing process early is that the pieces that are required in order to run those full test cases are simply not available yet. They haven't been built. They're under construction. They're undergoing change. Maybe the spec has been defined, but the implementation hasn't happened yet. So how do I test against it? Well, in a composite application environment, it may be that the piece that I want to test is ready for test, but it relies upon another component that isn't available for whatever reason, for resources, or it's simply not done yet. Well, with service virtualization, and this is a new technology, it's a new concept that's being provided by a couple of vendors. HP is one of the vendors that has announced recently a service virtualization product. ITKO is one of the early movers in that space, providing a product called Lisa Virtualize. And Parasoft as well has announced recently a virtualized product. And the concept is fairly simple. If you have the specs defined for a specific component, such as a web service or a set of REST APIs, that component can actually be simulated, and it can be virtualized. And so while you may be running the actual component that you want to test, that component is able to communicate with these virtual services which actually don't exist but are responding with what appears to be valid data to the component under test and allowing that test to proceed and allowing the functionality to be tested. So these are important and I think important and valuable steps forward in the industry and in the space, the technology space that we're in here, that allow teams to once again start the process earlier, move quality upstream, and make sure that they're identifying issues as early as possible. So service virtualization is something I recommend that you definitely have a look at. It's a young technology, and the approaches that the different vendors have is a little bit different from one to the next, but definitely a valuable technology that if you have large heterogeneous environments and systems, it's really worked out well for some teams, including the team that I've been talking about, the large ISV. They use this extensively, and it really helps them not have to spin up large numbers of virtual machines, not have to worry about having clusters available. They're able to use this not only to address the fact that maybe certain systems are not complete, but even the provisioning of those systems, which sometimes requires a large database on the back end or a significant amount of resources, well, they can just virtualize that and use test data to continue on with their testing. And 99 times out of 100, that serves their needs, and it works quite well. Okay, so that's service virtualization. Now, the last thing I'm going to chat about, I'm going to have to get a bit of a plug-in for our technology, which is something we call record replay automation. And the concept behind this is that you can record your applications under test and produce perfect recordings capturing all of the information around that application at the time of a test failure. And if that test failure is captured by a recording, the defect report will automatically include that recording, which contains all of the information about that particular test failure, providing a deep amount of information to your development team, your quality team, and allowing defects to be reproduced on a single workstation. So if, as we said earlier, if you have a large, complex, heterogeneous environment that requires a database and maybe some load on the server, well, having a record replay solution, such as the one on the screen here, which is Replay Director. It's our product. This is something that allows you to reproduce any problem captured without having to spin up a database, without having to generate load. By just pressing play on the recording, it's actually going to reproduce the problem at the source code level. So this is something that is really automating, if you will, the back end of the process. We're using tools like Selenium and QuickTest Pro to automate the running of the tests, the generation of the traffic and the load, and the discovery of the problems. Well, the solution will automate the capture of the problem, the reporting of the problem, and the reproduction of the problem on a single workstation. So this is something that's been very effective for all of our customers, obviously. And what happens is, as you're running through your tests, this system will actually detect failures, record those failures, and report on them, and then allow anybody on your team to take those recordings and put them into their development environments, their defect tracking system, and actually look at all of the details around that specific failure, such as what was my memory, what was my CPU, what exceptions might have been thrown, and specifically allow them to drill down to the code level and see the root cause of any problem, once again, without having to worry about spinning up the environment in which the problem occurred. So what they're able to do with this technology is enable a nice workflow that fits right into their development environment and their quality test environment, hooking into their automation systems, their defect tracking systems, and providing a really nice workflow around quickly identifying problems and pushing that automation all the way through deeper into the life cycle. And so the workflow that is enabled with all of these tools together is, as you're testing, Replay is in the background capturing your application behavior, recording it, and as a test failure occurs, a defect is discovered, the recording will capture and document that defect, including log files, screenshots, database dumps, web requests. All of that information is bundled up into that recording and included in the defect report in your defect tracking system, allowing your QA team and your even your support and ops team to collect all that information, diagnose the data quickly, and then enabling the developer to ultimately simply press play and see the root cause of that problem at a very deep level, right down to the source code level, in fact. And they don't have to worry about those difficult to reproduce problems. If you've captured a problem with this recording system, you'll have a guaranteed reproduction of the problem, once again, without having to set up any environment such as a database or even configuring the application. The recording takes care of all of that for you. So it's a very powerful system. We talked a little bit earlier about some of the patents behind it, but this is something that obviously has been effective for our customers and something I think is an important part of an important piece to consider if you are looking at extending your automation. Okay, so I'm going to wrap up with that. I appreciate everybody's attention. I'd like to get to some open discussion and see if folks have any questions. I'd be certainly curious to hear if anybody is familiar with or has experienced some of the application lifecycle intelligence products from HP.
Hi, Jonathan. Philip here. I have a question on the replay tool that you were talking about. Is there a facility to replay once a fix is done, to replay the same workflow and get the same messaging out and try that out? Or is it only a facility to show what has been induced first?
Yeah, what the technology does is actually hooks into the software and records all of the code execution. So when you replay, you're actually running the software again, and it's executing in the exact same way that it did when the recording was made. So every line of code that was executed will be once again replayed, and executed the same way, again, with 100% fidelity.
Okay.
What our system does is actually feeds in the same inputs to your application that were recorded when the problem happened, and essentially allows the program to return to the same state. And this is done at such a low level that even things like memory leaks, race conditions, thread context issues, exceptions, all will be reproduced. So anything that was difficult to reproduce is going to be reproduced easily and once again, without having to set up your database or anything of that nature.
Okay, I understand that, thanks. And just so that I can kind of get some context around it. So let's say we find an issue and the development team goes and fixes it, and now the fix is in an environment. Would we have the facility using the replay tool to replay the exact scenario which caused the issue, but on a new code base?
That's a great question. Our technology, because it's so low level, is coupled with the build. So this is really something used to help you reproduce problems. Now, once you make changes, you can extract some of that information to produce a test case that you can then add to your test automation suite, but the recording itself is coupled with the build. So it's sort of a two-step process that you would then use that recording to extract a test case that then you could add to your Selenium or your Quick Test Pro suite of tests or whatever automation system that you're using.
No, so so I understand this too, but what I was curious about is, let's say that for example, hypothetically, we have a web page where we've got QTP running and putting in two numbers and generating the addition of it. Now that fails, we've got a failure, replay records it, and we can replay the thing. Now what I'm saying is that if this bug is fixed, will replay be able to replay the same test again without us having to induce it from the automation suite? Is there a facility which will allow that?
No, not in that case. The recording is going to be coupled to the build. Yeah, but what you can do is extract a test case from that recording. Let's say you had multiple clients connecting, you could extract that test case and run that, or make that part of your automation suite.
Cool. Thanks.
Sure. Thank you. Are there any other questions?
Hi, Jonathan.
Yes.
Hi, Donna here. Based on your slides earlier about the continuous integration and the fact that, of course, more testing needs to be done, quickly revert back in terms of any problems found, also to run a full test suite. Have you had any situation where actually we are not in a position as testers to get the developers to do it, and how did you overcome that?
Well, the most effective systems are effectively automated, where it's agreed upon up front that if any of the tests during the continuous integration process fail, that check-in will be kicked out of the system and reverted back. So it's not necessarily that there's somebody pulling a trigger and saying, this test is failed, therefore I'm going to revert that change. But you raise a good point. It certainly requires the buy-in from both sides of the team. It requires buy-in from the developers to really understand that the sooner those issues are detected, even though it's sometimes a little bit painful when something simple breaks and it causes a check-in to be kicked out of the system. In my experience, teams will pretty quickly recognize the benefits of that when they realize that they're not having to spend a lot of time going back and one by one reverting check-ins to try and understand where a problem crept into the system. And I can certainly tell you that was the case for my team, which we used to spend a lot of time going back 5, 6 builds, rebuilding, trying to understand what was the change that caused this impact. And it really is a painful process. So there's a short-term pain for a very long-term gain by being fairly strict about that. And I think most developers will recognize that.
Cool. And just lastly, which application did you mention earlier that showed the build difference?
Yeah, that's a product. This is one example. There's a few of them out there, but that was a product called App Dynamics.
Okay. Thanks.
Sure. All right. Are there any other questions I can answer? Has anybody heard of application lifecycle intelligence? Has anybody had any exposure to that? No takers on the line? Is everybody familiar with the million monkey idiom?
Well, the line is quite quiet now, so I'll say I haven't heard of it until now.
Okay. Well, just Google that one. It's an interesting sort of philosophical question about whether a million monkeys with a million keyboards could produce all the works of Shakespeare given an infinite amount of time. It's often related to in terms of the futility of 100% manual testing effort.
Any other questions on the line before we wrap it up?
Yes, hello.
Yep, go ahead, please.
I'm just curious. So do you envision in this all continuous integration setup, do you envision the QA team to also write unit tests that would help out the dev team, or how do you segregate the team?
Yeah, great question. I would say the most effective teams are going to be cross-matrix. So it should absolutely be part of the quality team's purview to develop test cases, develop unit tests, I should say, white box tests, actually be writing code. The closer they can get upstream to the developers, the better, and the more insight they have into code changes, the better. So the best, most effective quality teams I've seen are the ones where they have engineers, programmers on the quality teams that are writing code, writing test cases. When I say code, I mean white box test cases, and really getting in there and understanding the code base and actually doing debugging. That's been the most effective approach I've seen from all the teams I've worked with. It's the more expertise you have, and that's not to say that you don't need, and it isn't valuable to still have your manual testers and the folks that are doing the test scripting. That's very critical. But if you can share that knowledge and have engineering talent and programming ability in the quality team, I've seen that be extraordinarily effective.
Okay, and a follow-up question. So if we end up automating a lot of the tasks, like what do you envision to be the ratio between developers and QA folks?
That's a good question as well. I think most organizations that I've seen have a ratio of about 1 to 3, so one tester for 3 developers. But it really depends, because if you start to get into more, hybrid roles where you've got your quality teams actually doing test creation and actual programming, that ratio may change a little bit. But that's typically been the ratio that I've seen.
Cool. Thank you.
Great.
Any other
So
questions?
I'm obligated to say if anybody has any questions, I should have put my email address up here, but it is just jonathan@replaysolutions.com. Let me just do that really quickly so everybody has it. So I would welcome your questions or any comments you might have. Please do reach out. And if you wanted any more information about any of the tools that I talked about, I'll be happy to share what I know, or if you want me to recap anything, please feel free to reach out. I'd love to hear from you.
And I will put the presentation as well as the recording on the TDO QA Speaker Series site. So if you'd like to refer to it again and the email address, you'll find it there by the end of the day today. So, Jonathan, thank you so much. That was very interesting and very informative. We appreciate your time and your knowledge here, and thanks everybody else on the phone.
Well, thank you. I really appreciate the opportunity.
Anytime. Thank you. And, Jonathan, if you don't mind, please click the recording and save. And this way we have a copy stopped, and it will ask you to save.